Okay, welcome back. So by now, I'm assuming that you've been paying attention in class and you know your derivative rules, your constant multiple rule, your sum and difference rule, your product and quotient rule. We just need to practice using them. So I'm assuming that you've read the book and you're ready to do this. So let's go ahead and dive in. I am going to rewrite this problem. Let me scoot this down here. Just rewrite it a little bit larger so you can see it. It's giving us that y is equal to 3x squared minus 12x minus 5x to the negative 2. So what I've done is I've taken a snapshot of the online homework and online practice problems, and I just want to work them through with you. It's telling us to find the first derivative and the second derivative, and I have the answer. This is the answers, so I already have those typed in. I just want to talk it through together. Remember that dy dx means in essence y prime, and remember that d squared y dx squared means y double prime. So we're going to be finding y prime and y double prime. All right, let's go ahead and jump in. So remember that the derivative of a difference is the difference in the derivative. So here we have many terms connected by subtraction, so we'll just differentiate each term. So the derivative of 3x squared, utilizing our power rule along with our constant multiple rule. So what I say is just pull the 2 down front, and you could even write it as 2 times 3x, and then remember to subtract 1 from the exponent, so x to the 1. So that's for the first term. Hopefully you're thinking that the derivative of 12x is just 12. So it's connected by subtraction. And hopefully you're thinking that we'll take this negative 2, again, swing it out front and multiply it by the 5. So eventually you'll arrive at positive 10x, and then subtract 1 from the exponent, so to the negative third. Now if you arrive here, you got to clean it up, right? So 2 times 3x is 6x. So you have 6x minus 12, plus 10x to the negative third. And you're seeing that's what I have typed in as the answer right there. Okay. Then when you go to get the second derivative, now you're going to, note to self, differentiate again. So now take this and take its derivative. All right, so then we'll go for y double prime. Well, the derivative of 6x, just 6. And the derivative of 12, the derivative of a constant, is 0. You can write minus 0 if you want. And the derivative of this term, well, again, we're going to take that negative 3, swing it out front, multiply it by the 10 to get to negative 30x, and then deduct 1 from negative 3, and you've got negative 4. Okay. So you arrive, after all that, you arrive at 6 minus 30x to the negative 4. And you can see that's what I have typed in right here. Okay. So, and a lot of people say, should I move x to the negative 4 downstairs in the denominator and call it 30 over x to the 4th? That's just a style thing. As you can see, the computer accepted my answer typed in that way. So I wouldn't be fussy on that. Okay, the next one I want to practice with you is a product rule. I'm really going to try, and you see I'm trying to zoom in on this so you can see it. Okay, so it says find y prime by applying the product rule and multiplying, and then try it in a different way by actually multiplying these polynomials out and then taking the derivative. So first I want to practice just using the product rule. So remember, if you want to differentiate, well, I'm just actually, you know what, I'm going to say it in words. If you want to differentiate this product, 7 minus x squared times x, so I'm rewriting the original up here, times x cubed minus 4x plus 3. What I like to do, that's a minus right there, what I like to do is remember that I call this first and second. So remember that the product rule says first times the derivative of the second plus second times the derivative of the first. So okay, so as I talk you through this, I'm going to be referring to this as the first function, if you will, and this is the second function. So, okay, so when we go to find y prime then, first function, 7 minus x squared, times the derivative of the second function. So, what's the derivative of x cubed? Well, 3x squared. And the derivative of negative 4x is just negative 4. And the derivative of 3 is nothing, is 0. So, okay, first function times the derivative of the second, plus second function, which is x cubed minus 4x plus 3, times the derivative of the first function. Well, the derivative of this is just negative 2x. So here's the thing. I always tell my students that if you arrive here, the students in my live classroom, that if you arrive here, I'm happy, But now notice the author wants you to it says fully expand your answer. So in other words, they're always going to want you to clean that up in the online homework. I'm under the general assumption that you know how to FOIL, but let's go ahead and practice cleaning that up. So 7 times 3x squared is 21x squared. Outer makes negative 28. Inner makes negative 3x to the fourth. And last is positive 4x squared. Okay, and then, obviously you have to distribute that. So negative 2x to the fourth. And then positive 8x squared. And then negative 6x. Okay. When you arrive there, just keep cleaning. So combine the like terms. So 21x squared goes with 4x squared to become 25. And then plus another 8. That's going to lead you to your 33x squared. And now we go ahead and look for more like terms. So, negative 3x to the fourth and negative 2x to the fourth go together to become minus 5x to the fourth. And then negative 6 doesn't have anybody to go with. No like term with that. And negative 28 doesn't have anybody to go with. All right, so we arrive here, and notice I don't even have that in descending order. And notice when I typed that into the computer, I didn't even bother putting that in descending order, and it still accepted it. And then I did want to mention, it says in Part B to find y prime by first multiplying the factors out to produce a sum of simpler terms and then differentiate. Well, clearly if you do that, you're going to arrive at the same answer, and I'll let you experiment with that. So note to self, you can experiment with multiplying this first. And then, you could dodge the product rule completely, because if you multiply that out, you'll have, an expanded polynomial, and you can just use your, sum and difference rules. So, all right, hope that helps. Then that takes care of our product rule. And then the last one for today is the quotient rule. Okay, so I'll make this, cherry pick this problem. It says find the derivative of this lovely quotient here. I'll make it a little bit larger. So it says y is 7x minus 6 over 9x plus 1. I remember in high school when I took AP Calc, I'll give a shout out to Harriet Rosenstein. She taught me low D high minus high D low over low low. So low D high minus high D low over low low. And all that is a cutesy little thing to help you remember that you're taking the bottom times the derivative of the top minus top, high meaning top, times the derivative of the low, the bottom, over bottom squared. So I'm going to talk you through that. All right. So, okay. Bottom function, low, bottom function, times the derivative of the top function. Well, what's the derivative of 7x minus 6? Well, the derivative of that's just 7. So bottom times the derivative of the top minus top function times the derivative of the bottom. The derivative of the bottom is 9. All over low low. Low low means bottom squared. a 9x plus 1 whole thing squared. Now, like I said, for me in my live class, if you put this on your test, I am very happy because you've illustrated the quotient rule, okay? But clearly, the computer is going to want us to clean it up. You can see I've typed in the answer there. There's the answer. Now, so let's practice cleaning. All right, so 9x times 7 is 63x. 1 times 7 is 7. Okay, and then distribute. So the author's always going to want you to clean things up, even when you check your answer in the back of the book. So then minus 63x, eventually plus 54, all over the bottom squared. Now you could see sometimes when you clean things up in the numerator, things will cancel out, terms will cancel out. 54 and 7 will make 61. So you'll have 61 over 9x plus 1 whole thing squared, which is what you see here, right here, in the answer. Okay? So, you know, definitely practice using the quotient rule. And like I said, if it helps you, you know, when you're first learning, you might even want to write a recipe here, like bottom times the derivative of top minus top function times the derivative of bottom over bottom meaning denominator, squared, okay? Otherwise known as low d high minus high d low over low low. All right, hope that helps, guys. Happy practicing.